Yesterday we had the fourth breakout session about signal processing and networking interface. Myself, Tanguy, and Ismail were leading the session. I started off by talking about, by recapturing the goal and motivation behind this breakout, being cross-layer open discussion with research communities in the intersection between Phi and NET. And specifically, we tried and challenged and refined the tools and methods used to conduct end-to-end millimeter wave research, focusing on the network simulator NS3 and some ray tracing thoughts. And then we tried to stimulate some discussions about other potential research topics related to this CSP-NET interface. So I started by talking about something that I've created in the last few months after the last workshop. As promised, I created this website, a shared website. It's a Google site where anybody interested can participate and edit and add thoughts and ideas. And as you can see, this is the structure. You have different pages, and we've, based on the third workshop, NSF RCN workshop, we've spotted some topics of interest. As you can see here, we have some MIMO channel characterization, some thoughts about error models and link to system abstraction, and simulation scalability and complexity reduction for channel simulation, millimeter wave channel simulations. We've had 3 WebEx calls offline between these workshops, focusing on these 3 topics with a bunch of people involved. We are 23 participants across industry, academia, NIST, research labs, and so on and so forth. So as you can see, the format is as is indicated here. Every page has its own topic and a hyperlink to a Dropbox page where I upload recordings of the WebEx plus the slides of each presentation. So this is just so you know, and if you're interested, please participate, ask me to access. So related to yesterday's discussions in general, the main topics that were also captured and discussed across the WebEx meetings in the last couple of months are as follow: channel models, ray tracing, blockage, antenna partner orientation, hand rotation, Phi abstraction, and simulation scalability. So we started off with a little bit of background on simulating the MIMO millimeter wave channel in NS3, both for 3GPP NR as implemented by NYU and for IEEE 11AY as implemented by NIST. So this was an overview. Most of you are familiar with this snapshot, and this framework is the end-to-end millimeter wave module developed at NYU in collaboration with the University of Padova that got recently published in COMST in 2018. Where you can find all the details. Then we briefly talked about the channel generation procedures as indicated in 3GPP, which are step-by-step the ways we have in NS3 the channel initialization, the MIMO millimeter wave channel initializations with channel metrics, spatial signatures, complex values, and a lot of complexity indeed. We've also shown that we validated some of the optional features proposed by 3GPP in 38.900, like self-blockage, spatial consistency. And this is just to show the audience that this is what we have. And we would like, to get feedbacks and people, if interested, to tweak this or just use this because it's an open source tool. And then we've also talked about the synchronization that we've recently integrated, really following line by line the 3GPP guidelines in release 15 with SS burst periodicities and a very detailed OFDM symbol tracking based on that, and also showing that what we can do is not only 3GPP procedures, but also plugging our own measurements, the sounding, and basically get some TCP and higher layer performance evaluations. So this was my first part of the presentation about NS3 millimeter wave channels. Then NIST talked about their very impressive tool developed in MATLAB for the 11AY simulation in NS3 also. I want to stress this because we believe it's the right tool to do a lot of joint works. So they talked about this quasi-deterministic channel model implemented in MATLAB, which will also be released as part of the WLAN toolbox in September this year. And that's being used in conjunction with NS3 to provide this physical layer for simulating end-to-end 11AY, basically. And then Ismail jumped on stage and talked about some of their preliminary measurements with propagation statistics, beamforming, the effect of beam shape on angular spread through their ray tracing tool, and some modeling of blockage and multipath energy in the angular domain in vehicular networks. The second part of the presentation was about abstraction, physical abstraction, and this is where we've got the best insights, and I think there's a lot of space for improvements, joint improvements. As I mentioned earlier, it's key to simplify as much as we can the simulator, the channel part of the simulator, and try and minimize the complexity of the MIMO channel specifically. So I briefly talked about mutual information-based link-to-system abstraction, which is the globally accepted solution to do this sort of abstractions. So I got the audience to better understand what we have there. And specifically, the most important part is this. These are link-level AWGN curves used in LTE for the OFDM evaluation methodology. And what I've openly asked for is help or advice about implementing the new link level defined in NR release 15 to basically rerun these performance curves and refine our error model, because as of today it's based on LTE OFDM at 20 megahertz, and this is even it's just an AWGN channel. But I will recap in the end. So the other part was NIST talking about their error model for 11AY, which is indeed different, and they're working on this, also based on a MATLAB implementation that's part of the 11AD WLAN system toolbox. The last topic we've discussed, so basically just to recap, we've talked about channel, MIMO channel, millimeter wave, both 11AY and 3GPP NR. We've talked about phi abstraction, and then as I stressed earlier, the importance of scalability. We've shown some preliminary results where with one single link, the bottleneck of the complexity is on the higher layers. The TCP and IP takes most of the runtime computation with one link. UDP traffic indeed is easier because you don't have congestion control algorithms. And then what we've shown indeed is if you start and grow the number of base stations and users, the bottleneck becomes the millimeter wave module. Channel metrics, interference computation. So what we've proposed and implemented already is some decoupling for the channel metrics to make it more runtime, but it's still very complex, and it takes a long time to simulate multiple users and multiple base stations. So we're working on another technique where, in collaboration with Nokia, we're discussing with Nokia because they're having very similar ideas. So we might end up doing the same together. They're very open to open sourcing this. It's down selecting some clusters to minimize the computational burden. So this was the third part, and let me now wrap up with this slide where I want you to see what are the next joint steps and a little bit of a call to actions. So link level millimeter wave simulation to improve and refine the phi abstraction for millimeter wave end-to-end and R. Working together, if you have ideas about this channel complexity reduction, I think it's an interesting also research topic. We could use technique, maybe machine learning, but it might be, we've tried and we don't think it's the right way, but if anybody has ideas, we're happy to sit together. Integrating and testing new channel blockage and rotation models, because it's such a modular tool, we can easily plug and play different models and compare. And this was assist to Ted's keynote where he talked about NYU SIM and comp, so maybe we can integrate all that and show the performance, the end-to-end performance differences when you plug these different models. And please reach out to me or to Ismail. I forgot to put their email, sorry, but it's enough to reach out to me for joining in future WebEx sessions that we will have offline between workshops. Just sit in, give ideas, get inspired, do whatever you want. There's a hyperlink here. You'll get the slides so you can click and get to the website. And please know that we would be happy to have you join the NS3 millimeter community, either 11AY or 3GPP NR. There's a lot of documentations and tutorials. The learning curve is not that steep, and we would be happy to help. Open source is key to acceleration. Thank you.
Thank you. So that's a great summary, Marco, great readout. A couple of questions. So one, and this is going to be really, and I want you to sit in front because you're going to be part of the panel discussion here. So the error rate performance was to actually maybe put it at abstraction of the file layer at that level into your NS3 simulations rather than implementing. That's what the goal of this link error model. Okay, and then file layer right now, is it still single beam in your implementation?
Oh, not at all.
Oh, you don't have? Because
No. It's multiple beams.
You can do multiple beams and multiple channels. Yeah. Okay, well.
You can easily plug that in. Right now we're doing, you can easily do multi-user MIMO with the way it's implemented today.
Excellent. Yeah, one question I had asked you last Asilomar, I think, or some 2017, I don't know. Can you estimate latency?
Of course. Yeah.
So what's the shortest latency in reasonable scenarios that you've been able to get?
Oh, so we've shown, it depends on where the server is sitting, right? So when we do edge simulation, where the server is sitting pretty close to the user, we're able to show that thanks to the frame structure, NR frame structure, and the retransmission procedures, you can easily hit the 1 millisecond.
But that means that everything is on the edge, all the information.
What's that?
All the information is on the edge.
Yeah.
So which the physical distance is maybe hundreds of meters.
Yeah.
So okay.
So it's pretty easy. And also through handover, because we've implemented this dual connectivity framework where you have sub-6 and millimeter wave. As soon as you lose the millimeter wave link, you can very quickly maintaining the millisecond latency thanks to these lean handover procedures. Enabled by this framework.
And then you also have the NR standard components in there, it seemed like.
Yeah, highly customizable. Yeah.
Very good.